Okay, so now we're going to look at rule number 2. So I have radical 5 and radical 6 for number 1. So to solve this problem, all right, our biggest concern right now is we have a radical in the denominator, and we can't have a radical in the denominator. So how do we get rid of that? Well, what we do is we want to make this radical become a whole number in the denominator. So I'm going to multiply by radical 6 over radical 6, because whatever number's in the radical, multiply the top and the bottom by that. And it's like multiplying by 1, because radical 6 over radical 6 is essentially 1. So if I multiply by 1, it doesn't change it. All right, so the top, 5 times 6 becomes radical 30. The bottom, radical 6 times radical 6, that just becomes radical 36. Okay, radical 30, are there any of our special numbers that divide evenly into radical 30? That's what we got to look at here. All right, so let me write my special numbers down again. Okay, so do any of those numbers divide into radical 30? I don't think so. So that number on top is going to say radical 30. That's okay. None of the numbers divide into it. Do any of those numbers divide into radical 36? Well, 36 does. So what is the square root of 36? Since it's one of the numbers, the square root of 36 is 6. And then that's our answer for the first one. And you can't reduce it because one's underneath the radical and one is not. All right. Number 2. Number 2 is another way of rewriting this. So we can write this as radical 3 over radical 7. All right. So again, what I got to do is I got to get rid of this radical 7. So I'm going to multiply the top and bottom by radical 7 over radical 7. 3 times 7 is radical 21. Radical 7 times radical 7 is radical 49. All right. Do any of these numbers divide into 21? Nope. 16 does not divide. 9 does not divide. 4 does not divide into 21. It's got to divide in evenly. All right. Do any of these numbers divide into 49? Well, 49 is one of our numbers. So what's the square root of 49? The square root of 49 is 7. And again, you can't reduce these because one's in the radical and one is not in the radical. All right, now for the fun problems on the bottom. When you have a binomial on the bottom, notice how I have 2 things. One thing that's outside and one thing that's inside. Over here, I just had one thing on the bottom and one thing on the bottom. So to get rid of that, you multiply by what's called a conjugate. So the conjugate would be 6 minus radical 2. So it's basically the same thing, just the sign is opposite. And whatever I do to the bottom, I have to do the same thing to the top. So on the top, this is a monomial times a binomial, so I'm just going to distribute my 3. So 3 times 6 is 18. 3 times radical 2 is negative 3 radical 2. That part's fairly easy, okay? Again, I'm going to look to make sure none of these numbers divide into 2. They don't, so the top's good. Top is set. Nothing else I can do with that. The bottom I'm going to multiply. I'm going to FOIL this. Everybody's favorite 4 little F word, right? So 6 times 6 is 36. 6 times negative radical 2 is negative 6 radical 2. Radical 2 times 6 is positive 6 radical 2. Radical 2 times negative 2 is negative radical 4. Now you might be saying, well, you just created more radicals than what we had. Well, I did, but if you look at this, it's actually going to work out for us. The middle, if I have a negative 6 radical 2 and a positive 6 radical 2, those are obviously going to cancel. Awesome. And then the square root of 4 we know is 2. So I know that this is going to become a minus 2. So I've got 18 minus 3 radical 2 over 36 minus 2, which is 34. Okay, again, what we're trying to do is get rid of our radical in the denominator, which we did. And then our lonely radical, do any of these numbers divide into that? Nope, so that one's good. Okay, for number 4, we're going to multiply both the top and bottoms by 2 plus radical 3 over 2 plus radical 3. Helps if I can write. And again, we're multiplying by the same thing that's on the bottom. We're just switching our sign. Over here, it was an addition sign to begin with, so we multiply by a subtraction sign. Over here, it's a subtraction sign, so we multiply by an addition sign. So I'm going to take 5 times 2, which is 10. I'm going to take 5 times radical 3, which is 5 radical 3. On the bottom, I'm going to take 2 times 2, which is 4. 2 times radical 3 is 2 radical 3. 2 times negative radical 3 is negative 2 radical 3. Negative radical 3 times radical 3 is negative radical 9. And again, our middles are always going to cancel out if we did this correctly. So the top, is there any of these numbers that go into radical 3? Nope. So that's going to stay as 10 plus 5 radical 3. On the bottom, the 2 radical 3's cancel, like they always will. and I'm going to be left with 4 minus the square root of 9 is 3. So 4 minus 3 is 1. So you could have that as an answer, or you could just not even have the 1 there at all because it's on the bottom, and have that as your answer. It doesn't matter which one, okay? And that's how you do rule number 2 with radicals.